Okay, so I just wanted to, okay. So I wanted to bring the subject of big data and artificial intelligence. So I would say that we are nowadays in a, what I call data revolution. So we are having tons of data, and actually the talk before showed amazing data of super complex networks that were from real data, right? So, and we have the possibility now to measure, for example, in my field of expertise, that it's neuroscience, we can measure hundreds of neurons, thousands of neurons through development. For example, we saw a talk showing the development of a zebrafish, and we can follow neurons there. We can also, as the talk before was showing, record from different regions in the brain, in human brains, isolating them and identifying it. So fMRI, we can also do imaging, we can do like so many things. So the problem now is what to do with this data. Another example is the social networks. Okay, so this has been a revolution. We have so much information about humans, how they relate, what they are interested in, so much data. So the challenge is how to extract information from data. How and coming from nonlinear dynamics is not just how we extract information, but what we would like to do is to unveil the underlying mechanisms of the emergence behavior of a given network. Okay. So artificial intelligence doesn't care about this. Okay, so artificial intelligence is a great tool to extract information from complex network from big data, but artificial intelligence is saying, I don't care about the underlying mechanisms. Give me some data, I can classify it, I can build convolutional neural networks, IMS networks, and I can generalize and classify your networks, give you things that you cannot do by eye or using simple tools of nonlinear dynamics, but they are not saying anything about the underlying mechanisms. That is what we are generally focusing. So I think the challenge there is how to put both words together. We cannot keep like ignoring each other. So I would say like the major challenge from one of the major challenges from from nonlinear dynamics is how to extract relevant information of the underlying mechanisms in networks, but also how to study the nonlinear dynamics of these networks of artificial intelligence. So for example, to analyze the dynamics in the latent space, that is the minimal space in a convolutional network, and how does relate to actual flows. So there are some works that has been done in that respect. So I think we had to, as from nonlinear dynamics, start like jumping into this artificial intelligence word that it's there.
Thank you, Anna. Hilda?
Okay, thank you. So, thank you, Anna. Very nice. So, I think I'm going to. I mean, I've been trying to see what to. I'll tell you a couple of things only that I have got and were very good from this conference. Well, uh, in a way, a synthesis of what has happened in a long time. I mean, there are many problems that take a very long time to solve. And what I had seen in this conference is that a huge problem that was not yet solved, that it was started by Kaneko in the early 90s, that it was the breakdown of the law of large numbers, which is, from the point of view statistical mechanics, a very important point. And the thing that I saw, I mean, and and many people around here have been participating in going there. I mean, Sudeshna, Ram, Gade, I mean, Lima. Uh, so I'm sorry if I'm not nominating everybody. And, uh, and I was very satisfied to see that Sergei flag brought some light into the problem when when he showed us when he showed us these examples of the Josephson junctions. So that is something. If he gets now, I mean, if we were talking about it, gets now some people experimentalists interested, because when Kaneko had that idea, those experiments were, if not only very expensive, practically impossible. But with the development of nanotechnology nowadays, at least that part is solved. All you have to have is the goodwill and the money to do it, but it's not that the experiments are impossible. So that made me, I mean, made me happy to see that something seems to have to be, we may be able to close that chapter. The other point that I think it's very, very important for Night to the Future, which in a way coincides with some of the points of Anna, is to see the applications, is to see the applications in real life. Like, for instance, I mean, just to tell you something, I mean, remember yesterday the talk by Sam Reedy, uh, that the use of things like fractal dimensions and in turbulences, and you could use something like that in a not very complicated way, very easy to do and not necessarily expensive, to set up something in the doctor's office to be able to check if a person really has, for instance, a crisis, an epileptic crisis. It could be done. I mean, it could be done, not very complicated, not expensive necessarily. So this is something that the field can bring to the society. And finally, is another thing that I wanted to tell the young people. We love research. And since we love research, that's what we want to continue doing, no matter what, I'm talking about as if I were very young, after getting the degree. But what I want to tell you is uh, all the challenges that Anna just described with the artificial intelligence need people who have a special ways of handling computers and things of the sort. And I think that physicists who had been trained in nonlinear dynamics are more adapted to that kind of problem than people who get degrees in computer sciences. I'm sorry that I'm saying this, but I have seen people on those sides, and the difference is probably the people in the computer sciences know a lot of things, but the physicists have a different approach, and what they know is how to interpret what comes out of that baremang of data that we get. So this is what I say, is that nowadays when you think of where you are going to work, not just academic is the most important thing to do. So, think about you going out also. Thank you very much.
I'm just going to move to the floor right now, Rajashri. Just to break it up a little, if you don't mind, Michael and Miguel.
I hate making any kinds of remarks about anything, but I have to say a few things. It's been a wonderful conference, and it's really been invigorating to me to be able to attend with people actually in the room, people giving talks. After a long time, I finally, this year, I have been able to come to conferences twice that have been well attended, and lots of new ideas and thoughts that people have been thinking during the pandemic are coming forth. So maybe it's not a bad idea to have the 3-year period between the PNLDs to reconsider what are the new things that are happening. Seems like a very nice period in between conferences to summarize and then sort of regroup and think about new directions. One thing I do want to mention is that, being an experimentalist in a room full of theorists is oftentimes somewhat intimidating because I understand so little of the theory that's being presented, and it takes me a long time to delve into something and then figure out how to do an experiment that will relate to that. And I think we need collaborations and working with theorists. Experimentalists need that to be able to motivate us to do things. And on the other hand, the feedback goes the other way as well, that it's really a good idea for theorists to pay attention to the experimental results, but not only just the data that's available, but actually work with experimentalists to see what kind of data they should be taking. What are the measurements that are really meaningful? And how to spot good measurements versus many measurements that can be taken. You can be inundated with lots of data and it makes no sense. So I think there's a lot of need to filter data and understand what is really meaningful, what are the kinds of measurements that are possible, what are the new technologies that are coming into play. And it's a great thing for me to come to India and see how many of you are utilizing those new technologies to start doing experiments at a place like IIT Madras, at other centers around India. Uh, that apparatus can actually be built and repaired in the country. This is a huge advance beyond what I experienced 40 years ago when I graduated and was thinking of how to do experiments in different contexts. So I will end there. I think this is something that I think is really interesting. Build your apparatus, know the insides of these things. Don't just leave things as black boxes. Fiddle with things inside out, okay? And learn about how to do the right measurements. Puneet is here. I know Anna is here. These are all folks who know their apparatus, okay? This is the kind of thing that needs to spread like a pandemic, like an epidemic amongst all you students and postdocs and young folks who are here and have the energy to make these things happen in the future. So I'm looking forward to this kind of collaboration and interactions between people like Sarthak, lots of others, that will make things happen.
Absolutely. We look forward to that. Michael?
No.
You give it to
I've got 3 microphones now, so that's okay. I was going to say pretty much what Anna said. The advantage of not going first is you can just say that, right? And just say, I think what she thinks. But I'll start instead by picking up on something that Raj said, which is go beyond the black box. And I agree with that in the context of experimentalists and theoreticians collaborating. I guess you would call me a theoretician because I don't do experiments, but I don't do all that much theory either.
I would like to categorize
But
so I'm totally happy for you to be an experimentalist and a theoretician.
but I see myself in some ways as a computational experimentalist.
Sure.
And although no one in their right mind would let me near an electronic circuit or a chemical reaction or anything remotely dangerous, computers are more and more powerful, can do more and more things. You can do more and more simulations on them at an unbelievable scale compared to even a few years ago. If you just think about the processing power of desktop GPUs today and what you can do with that. So I think the go beyond the black box also applies literally in the context of machine learning and AI and all of these things. I was talking with Miguel over afternoon tea, and he was asking me, he said to me, well, I remember going to a conference 20-something years ago about nonlinear time series. Has anything actually happened since then? I'm paraphrasing a little bit, but that was essentially what he was saying. And 20-something years ago, it was the fad. Everyone was good. Jurassic Park had just come out, and Jeff Goldblum had showed how chaos could solve all the world's problems or create dinosaurs, and everything was going to be solved by measuring correlation dimension and finding chaos in stochastic processes. A lot of the hype disappeared, but there is some reality underneath it. And in just the same way, machine learning and AI is at that stage where it's full of hype and promise and potential. In my opinion, vastly overblown hype and potential. If you believe that large language models are sentient, then I disagree with you. But there's a potential there to change the way that we do science. So if we think about how experimental computation works, all the talks we've seen at this conference, or almost all of them, and all the work that goes on computationally, it's an experiment. You do something on a computer and see what happens and try and figure it out. What machine learning offers is a possibility of suggesting solutions. So rather than simply doing an experiment to see what happens and then figuring it out, it can suggest directions. And I think in the future we're going to see more and more of that. We're going to see more hype and more promise that doesn't turn out to be true, and a lot of really shonky stuff because people have chucked some data they didn't understand because they didn't go beyond the black box. They've shoved their data into a machine learning algorithm, and because they didn't go beyond that black box, just believe the output and get nonsense. But there's promise for these technologies, for real science to happen. And I would just like to say one more thing while I've got the microphone. This wasn't part of my brief, but it was part of the questions that you raised. I think we also, in the post-pandemic era, need to think about what it means to have a conference, whether hybrid conferences are the solution, whether virtual conferences have value, or whether actually going to places and talking to people is useful. I know which one I think, but I was at another large conference in the US where they were seriously debating turning it into an online conference. And yeah, I mean, this was SciAm was looking at going online. And it works for some people, but I think it would be disastrous, particularly for young researchers. That's all.
Okay, my comments or perspectives are deeply rooted in physics. I want to speak about a physics perspective focusing in nonlinear dynamics and chaotic dynamics. I'm pretty aware that most of the talks in this conference and also in the community, there are people participating in them that are engineers, mathematicians, physicists, or maybe other disciplines. But there is something that worries me, is that as a physicist, I have the feeling that the physics community do not appreciate as we appreciate the methods of nonlinear dynamics. And I believe in part is because we need to apply the methods of nonlinear dynamics and chaotic dynamics to physical problems. And when I talk about physical problems, I talk about black hole dynamics, general relativity, cold atoms, nuclear physics, many-body physics, fundamental physics, astrophysics. There are already many applications in optics, especially nonlinear optics, laser physics. I believe Russ Roy can confirm this is due mainly to the pioneering work of Hermann Haken in 1976 when he found this resemblance between the Lorentz system and the laser equations. But it's really worries me. I mean, in the environments I move, such as the Physics Society, Academy of Science, European Physical Society, it's not clear what we can offer to the community. Because, of course, it's very interesting to, it has fascinated me as well, and I am the first that have made contributions to dynamics of cancer, to neurosciences, to ecology and many other biological problems, or even econophysics, etc. But in my opinion, this supposes a risk to be accepted by the physics community. We have a toolbox with many methods that I believe can be relevant for the applications in physics. Of course, I'm talking mainly in relation to what I understand and is the kind of research I used to do that may be called curiosity-driven research. So there are some questions that come to my mind. What breakthroughs are due in physics because of methods of nonlinear dynamics? Of course, we have also the problem of that many people perceive nonlinear dynamics as a part of mathematics, especially concerning dynamical systems. And also, there are a lot of applications in engineering. Jegor Litak is here as mechanical engineer. There are many applications in mechanical engineering. But in a word, I would like to just to say these words to propose also a debate whether we are doing, I mean, I repeat, I speak as a physicist, whether we have made the effort to communicate these ideas and apply these ideas to physics problems so that physicists can recognize us as, let's say, people who are doing research in the same direction as they do. I'm deeply convinced that the fundamental ideas of chaos and nonlinear dynamics are so fundamental that can be applied to any discipline in physics. Of course, there have been attempts in the past in different domains that probably that have been not successful, but still I think it would be worth to insist. I believe my message is clear, right?
Absolutely. Thank you, Miguel.
Okay, I feel a bit out of place speaking after hearing from people who are so much more. I mean, I feel a bit out of place speaking after some people so much more experienced than me have spoken. I am someone who is just towards the end of a postdoc, so I'm very, very relatively early in my career, and I can just say a little bit about what my view has been of the field and. Yes, okay, absolutely. So, so one aspect that I want to definitely talk about is going to sound like I'm repeating once again what people have said, and the context of like data and machine learning. Already enough has been said about how we're in the era where you can use machine learning tools and artificial intelligence tools to understand data. But the other aspect I want to also bring out, which I think briefly Anna you had mentioned, is that I see if I just look at like papers, like in communities that are as such completely dissociated from nonlinear dynamics per se. Like if I'm just looking at like machine learning conference papers and so on, even over there I can see, particularly in the last few years, there have been a lot more papers where people are interested in looking at what's going on inside these black boxes from tools from machine learning. From tools from dynamical systems. They're trying to look at the machine learning black boxes, and as a result, so I'm currently as a part of a neuroscience community at MIT. All of this is also, there's a lot of bi-directional seepage of information from people in neuroscience now thinking of, okay, neural circuits and trying to understand them as dynamical systems, which I think has a bit more of historical context. But definitely look at machine learning systems. There were dynamical systems people and physicists who did that way back, in classic golden era of machine learning. But there was this entire period where people had this very black box view, and very recently I see all this coming up again. So that is definitely something I see quite exciting in terms of what I think one of the important directions. I expect that to be an important direction simply because not only is this in the context of papers, but also when I talk to people who once again have no physics background, I see more and more people asking me about, oh, what should I read to understand dynamical systems and things like that. People who really would not have, their research directions would not have been looking at those kinds of problems. Yeah, I think that's one thing I want to say. I can just make one more small comment, which is, so my personal trajectory in research also relates very strongly to the comments you were raising, which is that, so through my PhD, I was working much more on abstract systems, which of course, they are motivated by problems in the real world. But there was also always this question of, okay, can you actually ground them? What is the physical application of this? It's very elegant. Which actually what motivated me towards, try to look for intersections of nonlinear dynamics with other kinds of fields. And I think, yeah, there are a lot of people, at least in my age group, I think of my cohort, who are thinking in similar ways, who are really trying to ask, okay, I have this toolkit that I've developed from nonlinear dynamics. Where can I apply it? And what are the applications I can actually see, and what is the direct impact I can observe? So yeah, that's just my perspective from what I see in my
Thank you,
cohort.
Sarthak.
Yeah.
I mean, it is, I think sometimes we forget that original sin was the Hopfield model, which came from physics, model of neural network, the entire artificial neural network is it's an invention of a physicist, and who's also being recognized this year by the statistical physics community with the Boltzmann medal. So, I mean, this is all at the root of the chat GPT revolution is physics finally. Anyway, thank you very much. Rahul, I'll come to you last. Huh? He has to? Give me. Rahul, please.
So I would like to build on something that Sartak was saying, that about the machine learning and everything. Like, I think people forget to look like exactly like what is going on, and much times like when you go to see like what a machine learning algorithm looks like when it reaches like its purpose, many times it's going towards an attractor, like and would be interesting to understand it better, because many times we find similarities between uh, the way that these artificial machines are working and brains works. So I think it's a really nice opportunity, because this is something that you can do like with our computers nowadays. And another thing that is a particular interest of mine is like, I think we have like a lot of work like in many areas, and we are always looking like to the final state of the system, like for example synchronization and if it's stable or not. And I think we should keep an eye open like for transients, maybe, because no one talks about that. No one talks that much about transients, but when we go and think about, like, we are always living transients, like in the ecological system, in brain activity, like, and I think would be nice to have a better understanding of like transients, I think. And okay.
Earlier, I actually asked Divakar and Divakar to put, to be part of I said that I'd come and ask him some questions, but he's gone to the airport. He asked me to, uh, again, I mean, summarizing what he's saying, the importance of looking at real data, large amounts of real data, and predicting things that are currently fashionable, like tipping points and critical transitions. But the emphasis on looking at real data and predicting, or at least analyzing it for extreme events or any of these things, rather than just models. So I think that that is something that he and Shamal together, they sent me some stuff. And what we've heard a lot of over the last few days, swarmolators, swarm earlier, swarm many things. The fact that you've got mobile agents or mobile elements that move, interact, and do things together or apart. I think that these are interesting areas from his point of view. Let me just throw the floor open. Uh, Anyone for a quick, short comment? I'm going to bring it down finally to Sudeshna. All right? No. I mean, I can drag you still. Okay, I mean, see, what is really nice to see at this PNLD back in Chennai is the very large number of students, in particular the large number of students who are still here on the fourth day. So, yeah, that has been rather nice. Um, okay, so anyway, Shan, okay. So let me at least the final comments, Sudeshna, on where you think the field is going, and then after you're wound down, we'll just announce the poster winners. Yeah.
But this, right, okay. So the thing about having this quote unquote last word is that, of course, all the words have been more or less said, but I'd still like to add two things. So there are these two buzzwords, and I think we can connect to them meaningfully. So the one, of course, is data science and machine learning. Everybody has said something about it, but let me add my two bits to it too. So there is this thing about, physics for AI and AI for physics. So in my head, this AI for physics is a bit of a black box. And I would say that perhaps the, thrust there will come from engineering, because we cannot almost match them for the cut code they can do. I mean, they're really good at it. However, physics for AI might be more interesting to us, because we sort of can maybe put into the box some principles, minimal principles, to make the box more interesting. We could try to open the box and check it out with some other principles which we can put in. So maybe the second question might offer a little more to the community. That's just my two bits for it. Yeah, maybe we'll have some ways of optimizing the box. The second thing which I didn't hear mentioned here, and probably was slightly underrepresented in this PNLD, could be in the next one, we could pick up on that, is the second buzzword is quantum, anything quantum. Quantum information, quantum computing, quantum stuff. And as we know, as Ram of course knows, because a whole lot of I mean, your generation more than me perhaps, is had so much focus on, say, quantum chaos. I think it's a great time to revive a lot of that effort,
Relativistic quantum
isn't
chaos.
that, yeah, because I've been going for some things, like I mean, I heard a bunch of string theorists the other day, and they were all into
Turbulence.
turbulence, quantum chaos. It's like, oh God, I think we knew this stuff 30 years ago. So that might connect to the fundamental things which people are trying. So I feel it may be a great time to go back and reconnect to things quantum, which we somehow, the activity died down a little, maybe lack of ideas in the field, but I think it's well. So this was, I don't know what you think about that, because, you know,
No, no, I think
Ram was
it's
the
very
quantum
good.
chaos,
No,
you know,
You know,
thing,
the advantage of being 99 years old is
Yeah.
that you've just been there, done that, and at the wrong time
Sudeshna,
usually.
may I just make a small interruption, not just on the thing that you said about quantum chaos. You're right. I mean, nobody's paying attention to that. But I will tell you that on the 21st of this month, we are starting a school on quantum chaos in Brazil, and people can watch it by Zoom if they want to. So, I mean, they won't be able on the hands-on, but they will be able to watch the lectures. And
difficult to have
yeah,
hands-on
which is,
quantum
and let me tell you, I mean, we had a serious, it was very difficult to convince the committee that a school on quantum chaos was about time to come in. So, I mean, everybody thinks that the whole thing is.
Let me
dead.
remind you, Hilda, that in 1990, you and I did a quantum chaos program in ICTP.
ICTP, and I
Don't
was
even
kind of
remind me that
student.
so much time has gone
It
by.
was wonderful.
Yeah. No, I mean, the more things change, the more they stay the same.
Right.
So we will
Absolutely.
be
I mean,
coming
it's
back.
So that whole thing, you know, finding a little bit of the new in all the old things.
Yeah.
Look at it with
I
new
know,
eyes.
I know that concerning
Sorry.
maybe the methodology of quantum chaos as it was established years ago, I think it has decayed. But
it has changed.
I know now there are some communities of quantum physicists working with ideas of chaos. I don't remember what's the name. I think it's a theory of something, the Sitter or whatever. Which they are using ideas because, I mean, as I mentioned before, they are deep ideas that needs to be pervaded all physics. And slowly, communities that years ago showed any interest in ideas coming from chaotic dynamics, they are applying right now.
No. Yeah, actually, the I think what is true is the following: that in the when chaos was new, and quantum chaos was even sort of newer part of chaos. So then there was a certain kind of an interest. Now I believe that nonlinear dynamics and the methods of chaos, they are bread and butter. It's almost like linear algebra. And so the questions that people are asking in quantum mechanics and quantum chaos are much more sophisticated and are at a totally different level from what was being, I mean, level statistics and wave functions, scars, etc., old stuff. Now it is, you know, completely new considerations, and quantum information is playing a major role. Entanglement with quantum chaos, even that is being done at a very sophisticated level now. So, I mean, so those are important areas.
Yeah.
Okay.
Yeah. So that was what I felt, that there was some opportunity there, which especially. I mean,
Yeah, and you know, there are traditions in this country where we have really studied a lot of integrable systems.
Right.
That has been a very important area, and there are new directions in that also that have to be explored. I think a little, more of network theory, but more sophisticated approaches in network theory. There is bread and butter physics that will go on. But I think it would be very useful to explore some of the newer areas, as has been stated around.
And maybe just one,
Yeah,
even
sure.
like in India, the other very strong tradition, as we know, is of statistical physics. So those interface areas also could be, especially for the newer people who might, have come from that background, might have a lot to do. Yeah, sure.
I want to be very brief. I mean, according to some of the ideas has been commented. Of course, nowadays everybody speaks about big data, machine learning, deep learning, etc., etc., etc. But this, not only physicists, everybody. And I think, in my opinion, there is something really important. As a scientist, I must say that something very important is understanding. Dealing with data without understanding, in my opinion, means nothing. So I support, in this context, big data and big theory.
Yeah.
Because without understanding, we cannot go anywhere.
Good. Thank you, Miguel. Sudeshna, should we wind down?
Yes, I'm done.
Please. We've asked, and whoever would like to speak, he may not have.
Or forever remain silent till the next
Yeah.
meeting. Or,
I don't want to go around hounding. Okay, Nurul Jaman,
yes.
Yeah.
not a
I
student,
also want
but
to say something.
Just I want to say one thing.
That's it.
In
Thank you. This is
in line with Professor Rajoshi Rai. So basically, what happens to our kind of experimentalist? So when we are doing small experiments, then when we come to this PNLD, we have seen they are doing oscillator, then all SOM oscillator. So the advancement is so fast, it looks like to the experimentalist that we are using a small Nokia phone and now things are going like smartphones. So my suggestions, uh, in next PNLD, will it be possible that theoretician will tell us, oh, you can translate this theory in this way to experiment. So that I think it lacks. And it is difficult for us to understand in terms of experiment. So that if there is in future this kind of experiment, a theory and experimental interaction, that will be fine. So that is my suggestion.
thank you, Nurul Jaman. Sudeshna? Okay, now this comes to the slight high point of for the poster presenters. We've had 2 days of posters. About 60 posters were there, plus or minus, and they've been evaluated. And we're very pleased to announce 5 prized, the top 5 posters that have been judged. Sudeshna will read them out.
Okay. So I have this wonderful, privilege and, to announce the top
And
5.
if your name is announced and you're here, please stand up.
Please stand up. And, right. So I hope I'm pronouncing your names right. So, so the first one is Raganya Chatterjee. Are you there?
who is she? She.
Huh? Raghan? Oh, there you are. Okay. Nice. Congratulations. Yeah. Shorobindu Dolmi.
All
Okay.
right.
There you are. Congratulations. Smita Deb. Congratulations. Calvin Alvarez. Congratulations. Parvez Khan. Are you there? Okay. Congratulations all. Now Ram will tell you what it really means.
Yeah, no, the mystery. I mean, the 5 of you will contact you on email, and you'll get the prizes to be announced later via email. I should also say that all participants will get their certificate of participation also by email, right? And well, that's sort
We
of.
need to thank Chaos.
I would like to suggest that the posters, the winners,
Yeah.
come here, and so
Yes,
they can
please.
take a picture
Yes.
and like a
That
proper
would be nice, yeah.
recognition of,
Would you
because
all
if
please
not, they
just
will
come
kind
over?
of come here. Don't be shy, and you.
Sponsors.
We'll do that and thank everybody. Actually, Nilima, you should also be on this
Yeah,
side
yeah,
over
please,
here,
please.
please.
Yeah,
Nee, nee,
come on, Nilima.
nee, Nilima, Shayan, come on.
Nilima, I mean, Dodo, in the photo.
Okay. Anyway, well done.
Congratulations, Dodo.
Thank you, Anna. Okay, really now these are just the final words from, all of us over here. Um, Thank you to all the participants and all the speakers, everybody. Thank you for being here for these last 4 days. It's been a very, very exciting time, an exciting conference. Well, it's the first big conference we are doing after the pandemic personally. So it's a pleasure to have everyone over here. There will be a series of last words, but let me get mine in before. On big one? Yeah. Okay. This is the seventh PNLD that we've been having. The first, has been told to you several times, was in IIT Madras in 2004. This was this was actually organized both by IMSC, which I neglected to mention, and IIT. So it was a joint effort at that time. From those days, this conference traveled to Trieste, Italy, to Bangalore. It then went to Hyderabad, and then went to Berlin, to Sao Paulo, and now we are back in Chennai. So it has had a journey. And Nilima and I have been associated with it from the beginning. Beg your pardon?
No. I attended the first.
Yeah, Hilda attended the
but
first.
I have not been associated.
Right, but as organizers, you and I have been constantly doing it, and the time also has come to move on. So we hope that this conference will survive. This is not an Indian conference by any means. This is a satellite to StatFiz. And so in the spirit of, as StatFiz moves around the world, the hope is that this conference stays as a satellite to that and moves along with it. I can give you the locations of where the earlier StatFizzes were. And as I mentioned right on the first day, this was to have been in China, closer to Tokyo, but nevertheless. So we will look forward to people taking up the sort of responsibility of organizing such a meeting. One of the advantages of doing it the way we've been doing it so far is that this has also been a place for the developing, for the people from the developing world who work in this area to find a platform to come together. And that has been important. Large part of the participants have been from India, but when we've had it in Trieste, it's been from all over. When it was in Sao Paulo, it was a large part of South America. Many people came from all over. So it does mix the global and the local in a very nice way, and we'd like to see that tradition continue. Right?
May I say just a very
Yes,
small
of
thing?
course.
I mean, you're right about this being an opportunity for the people from these parts of the world to get together. But the thing that I miss is that the world seems to have divided. I mean, the scientific world is at least the nonlinear dynamicists. It seems to me that in one place is the United States, and the rest of the world in another. I mean, two clusters. And except for a few exceptions, like for instance, Raj, we don't cross. So I think we should be careful that we also invite people from the United States to come.
We did.
You did, but they didn't come.
Yeah. Many of them are online. Anyway, look, your point taken, but let's see how it evolves in the future and what happens. Shayan and Nilima have been really bearing the brunt of the organization over here. Beg pardon? You will get it. You will get it. No, but before I give the mic to them, just wanted to take this this moment to express on behalf of all of us appreciation for them, for and all the volunteers, all the people involved from IIT Madras, the local organizing committee, and everything. Please join me in giving them a big round of applause. And now you can get the mic.
Yeah, so thank you all for coming. It has been a wonderful 4 days. It has been a very energizing 4 days. Okay, so I have to tell you that we essentially shanghaied this conference on the on the instructions of IIT Madras. Okay, and especially our Center for Complex Systems and Dynamics, which has participation from 8 departments of the institute. So it's a truly interdisciplinary group. So like I said in the beginning, we wanted you to come because firstly, we wanted to have a conference and we wanted also the community to see us and for us to see the community. And I think both things have been achieved. There has been a superhuman effort on part of my colleagues, and there has been a superhuman effort on the part of Sayan here, who's the head of CSD, and his whole team of volunteers, students, colleagues have done an admirable job. I don't even know who did what, so I'll ask him to say that.
Yeah, thanks, Nilima. But this was, as everyone mentioned, this was one of the big conferences that was held after the pandemic. So many things, we were doing it for the first time. Uh, First thing is about the funding. We were able to keep the registration costs as low as what we did, which does not even cover the lunch costs, simply because we got a huge amount of funds from IIT Madras. We thank IIT Madras for that. We also got some funds from SERB, some funds from CSIR, some funds from Chaos. Some funds have been promised by Chaos Solitons and Fractals. And
Their impact factor.
yeah.
You need to hold them to it.
And
It's recorded.
the poster session, poster prizes have been funded by one of our vendors, computer vendors, Micropoint Computers, who have been our go-to person, go-to vendor for any of our computer, high-performance computing facilities. And that's the academic part. We were also lucky to get support from our Bose Einstein Guest House, Taramani Guest House, our CCW for the hostels, as well as from Anna University, where we were able to get some, we were able to accommodate some of our guests. So thanks for that. We received a lot of support. Of course, Ram and Nilima were there to oversee everything, but we got a lot of support from our complex systems and dynamics colleagues. There are 8 or 9 names. So let me know, they are there in the website. It's just too big to name them. But my special thanks to my colleagues in my department who are also part of CSD, Anubhav and Farooq, who have been my, who have been, whatever cribs I had, I just had to go and talk to them and we sorted out things together. So thanks to them. And of course, this 4-day event would not have been possible without the tremendous work that was done by a group of my student volunteers. I mean, they were not really volunteers. They had been volunteered too.
They were student volunteers.
Yeah. And for the last 3 weeks, I think 2 or 3 of my students have been working full time on this. And for the last 4 days, a huge number of students, 9 or 10, and I've been I was just an administrator of a WhatsApp group. I just have to tell them something and it was getting done. And it actually ran on auto mode because of them. So we will have a
party sometime soon. Thank you very much. Yeah. Thank you very much. And thank you, all the invited speakers, all the contributors, all the poster presenters for making this event such a wonderful event. I learned a lot. I'm not from the physics community, so have been keeping quiet and trying to learn things. There is one small event still left, for which I will hand over the mic to. Oh, he already has.
No, no, this is something that, uh, we wanted to particularly. Come on, one by you and one by us. Nilima, you have really led everybody in this particular effort over here. You've led not only the community, you've led your colleagues here at IIT. And we, on behalf of all of us, would like to make a small presentation to you. Just some two nice books. Would you come up over there and have your photo taken with us? I'll give it again so that you can take a photograph.
I've been given all kinds of things in the last few days.
Wait, no. I mean, so again, this is on behalf of all of us. Sayan?
I'll give it to
No, you.
I'm supposed to.
This is for you.
Both of you.
Books are for me.
Yeah, both of you. One from him, one from me.
Two dictionaries.
Oh, you gave me the book. Oh, good. Thank you.
Yeah. Hey, Nilima. Photograph.
Three of us.
Yeah.
Yeah.
Okay, good. These are so heavy, you better carry them. Bye, everyone.
Bye. You said you're prepared. In your place, what's it?